The last thing we want to review when we're factoring quadratic expressions are two special cases. The first is a difference of two squares. It is called a difference of two squares because you have two perfect squares and a subtraction symbol, difference. When we see a difference of two perfect squares, what we can do is take the square root of the first term, the square root of the second term, that will give us our a and our b, and then we can just rewrite them in their factored form, writing a plus b and a minus b. So it's a real quick way of going about it. Another way we could treat this is we could do it the way we did before, but notice there is no middle term with an x, so we would say the sum is 0. But by being able to recognize these differences of squares will save a lot of time in the long run. Our first example is x squared minus 6. Those are both perfect squares. So I take the square root of each term. The square root of x squared is x. The square root of 16 is 4. I don't even worry about that minus sign. All I worry about with that right now is that it's a difference of squares, so I can apply this formula. If that was a plus sign, it would not be a difference of squares, it would be a sum of squares. This formula would not work. So now I'm just going to use x as my a and 4 as my b. X plus 4, x minus 4, and done, factored. See how much quicker that is? Now here's where the speed will really come into play. Here we have a quadratic expression where the leading coefficient is not 1. Remember how much work that was in our previous video? But if we look here, these are perfect squares. The square root of 9 is 3. The square root of b to the 4th is b squared. The square root of 200, is 200 a perfect square? I think it is. Let's double check. It's not. I picked a poor example. Okay, let's rewrite this example. Let's pretend that instead of 200, let me grab an eraser quick. Let's say this is a 400. All right, the square root of 400, that works. The square root of 400 is 20. Okay, so now I can use my formula. Wherever I see the a, I'll use a 3b squared. Whenever I see b, I will use 20. And that's it. Look how much faster that is than multiplying your a and your c, figuring out what multiplies to this, adds to that, rewriting it, grouping it, greatest common factor. This is why we want to know how to deal with these special cases. Last review topic, our second special case. This is called a perfect square trinomial. A perfect square trinomial starts with a perfect square, ends with a perfect square. And then in the middle, what you have is 2ab. Remember, a is the square root of the first term, b is the square root of the second term. So we'll see 2 times their product in the middle. And when we have these perfect square trinomials, we can factor them by just taking the square root of the front and the back, and then we use a plus sign. If the original has a plus sign in the front, we use a minus sign if the original has a minus sign in the front. Let's try a couple. If I check this, the square root of x squared is x, the square root of 9 is 3. They're both perfect squares. 2 times 3 times x is 6x. This is a perfect square trinomial. So now what I can do, since there's a plus sign right here, I can factor this to write x plus 3 quantity squared. Again, we see the speed really come into play when we have a leading coefficient that is not 1. If I take the square root of the front, I get 2x. If I take the square root of the back, it's 5. 2 times 5 is 10. 10 times 2 is 20. That's what's in the middle. This is a perfect square trinomial. So the factored form is simply 2x, I see a plus sign, plus 5, quantity squared. All right, that concludes our review of factoring quadratics. If you have more questions with this, I hope that you will join office hours at the beginning of the week, because the end of the week we're going to be focusing more in on how do we solve quadratic equations. All right?